Data Platform Women in Technology Virtual Group in our monthly meeting. You can reach us at our website at dataplatformwit.com. Our meetup site you already know how to get to, otherwise you wouldn't be here. We are on that thing called Twitter, advertising our sessions. And we use Blue Sky probably more than anything else because Twitter seems to be a dead doornail. We won't say why. We might get in trouble. Next month, we are hosting 2 sessions, one on March 11th, noon Eastern time. And let me move Teams out of the way so I can actually read it. Unleashing the Power of Azure SQL DB Hyperscale. And then March 17th, we're hosting one noon CET time for the European time zones. That's Latin presenting women of color, how I've navigated my success in technology. Today we have, now move my screen again so I can read again. Unlocking Smarter Document Processing with AI Tools by Andrea Rosales. I can't pronounce the name. So I will let her pronounce her last name. That would probably be better ideal. I am sorry, I'm terrible at names. It's my fault, totally. Now we will turn it over to her and let her do a much better job at pronouncing her last name than I did. I probably should have asked her before we started, but I forgot. So now we will let her take center stage. How did you want to take questions? Do you want me to interrupt you with questions if they come in chat, or?
Yeah, if there is anything in the chat, you can interrupt me. Otherwise, I'm so planning to leave 5 minutes at the end for any more specific question.
Okay, just wanted to double check. I'll let you take it away.
Perfect. So I'll just share my screen. Hope everyone can see that. Yeah.
Yes, we can.
Well, thank you so much for being here today. Yeah, I'm Andrea Rosales, and I'm very excited to share my journey and insights on document processing with you today. So, well, yeah, many organizations handle large volumes of documents, whether processing mortgage or employment applications or handling legal paperwork. The need for accurate and efficient data extraction is critical. So traditionally, this process has been manual, requiring significant human effort, which can lead to mistakes or overlooked errors. So in this presentation, I will explain how current AI tools can improve document processing. So this is what I'm going to share or cover today. So first, I'll give a brief overview of large language models to understand why document processing is successful. Then I will dive into document processing, talking about like development, testing, AI as an integrated solution. I'll cover some challenges that I faced during this development. Then I'll explain how our fraud check module works. I'll do a small demo of document processing and the fraud checks, and I'll leave some time in the end for questions. So, well, before we dive in, I'll just introduce myself quickly. I'm originally from Mexico City, and I've been living in the UK for the last 8 years. So my background is more on math and statistics, and I have a PhD in computer science from University of St Andrews in Scotland. In my PhD, I focus on transfer learning and unsupervised domain adaptation for human activity recognition. And currently, I work as a part-time research fellow at St Andrews University, working on continual learning and reinforcement learning. Apart from my academic background, I have 15 years of experience in the industry, working in different sectors as marketing, oil and gas, e-commerce, media, transport, and others. Yeah, I have experience in data science, deep learning, and most recently in Gen AI and large language models. In my current role at Colibri, I'm leading the design, development, and deployment of advanced Gen AI applications. And some of the use cases I've been working on are text summarization, document processing, text extraction, and fraud detection. I would like to start first with a brief recap of the development of large language model, highlighting how language barriers have been gradually overcome and to understand why document processing is successful nowadays. So the main models I'm going to talk about in this section are GPT models, which are the models that we use in our solution. And all these models are accessible on Azure OpenAI.
Excuse
So,
me. Are
yeah,
you advancing your slideshow? Because we're still seeing the first slide.
yes, I'm moving the slide. Um,
Okay, we may be seeing the wrong screen then, because what we're seeing is your web browser with
okay,
the. So I just wanted to see
okay,
if we
let me
could
just share
do that
the
before
maybe
you
the
got too
whole,
much further.
yeah, let me share the whole screen then. I was in this slide.
Okay, now we can see that, and now we can see the slideshow.
Yeah,
Thank
can
you.
it move? Okay,
Yes, there
perfect.
we
Sorry
go.
about.
That's all
Okay,
right. I just wanted to get that before you got too much further.
okay, no problem. So, yeah, to show the progress in text generation, I'm sharing some prompt results from different GPT generations. So, well, natural language processing gained great popularity after the end of World War II in 1945, when people realized through peace talks that translating from one language to another one was critical. So LLMs were originally developed to predict the next word, but in order to do it very accurately, LLMs developed a range of skills, right? Back in 2011, state-of-the-art language models couldn't even put together grammatical sentences. And here I'm showing an example of a prompt that is the meaning of life is, and we can see the results with very ambiguous responses, many covering different topics that doesn't really answer the original prompt, including some character recognition errors. Um, a big jump in text generation came with the development of GPT-2 in 2019, which was consistently able to generate coherent sentences containing relevant knowledge of the world. I'm putting here an example of Miley Cyrus that was caught shoplifting from Abercrombie and Fitch on Hollywood Boulevard today. And we can see the response of GPT-2 explaining the situation, what happened, which improved more from the previous version. A further jump came with GPT-3 in 2020, which was trained in a similar way as GPT-2, but with around 100 times more parameters. Here is another example of the prompt, and we can see how extensive and more detailed response we can get now from GPT-3. Last year, we have the release of GPT-4, that is a multimodal large language model that incorporates three main capabilities, that is creativity, visual input, and longer tests. So all these capabilities allow for deeper contextual understanding and multiple step reasoning. So these also make GPT-4 very efficient and understanding complex documents across different formats and languages. So yeah, what I'm trying to highlight with this slide is that all this progress in LLMs, in large language models, means that tasks which once require significant human effort now can be accelerated with these models. So let me rephrase this with this chart. So many of today's business challenges have been outdated. Problems like text extraction, chatbot, text summarizations, which once took the research and development team months to solve, can now be quickly addressed with foundation models. So let's understand why with this diagram. So uh, anyone familiar with building products has seen this chart, right? Every company wants to build a product that is feasible, desirable, and viable, right? So in the past, we will always ask questions before building our product, like this one. For example, if we wanted to build an autonomous car, the tech question will be, can we use machine learning to build it? If we can, then the design question will be, okay, will people buy it? But the strategy question is like, can we afford it? Because sometimes research and development takes so long or requires so much effort that companies just go back from. But nowadays, this tech question is partially answered or completely answered So in this case, our question was, can we use AI tools to extract text from documents? And the answer is yes. So we really didn't need to build a new AI algorithm or a new large language model for this task. We just needed to find the best technology to achieve this. So yeah, during our development and testing phase, we try many options, but here I'm showing the top 3 and the ideal ones for our use case and the ones that led to the final solution. Here in the title, I'm also including the date where we started all this development and testing. That was in 2024, February last year. Because by that time, the GPT model that was available was a GPT 3.5 Turbo and was available in Azure OpenAI. So our first option was to use Python libraries to extract the content of the document. So there are different Python libraries to extract content from PDFs, other libraries that are able to extract text from images, and so on. So once we have extracted that content, our next step was using GPT to extract the information that we needed. So we tried different prompt strategies, such as direct instructions or few-shot learning. But we realized that we were having a high rate character recognition errors because these Python libraries were not really accurate in extracting that content. And sometimes we also had, well, the data handling was also expensive in some cases when we were dealing with very long documents such as tenancy agreement, legal paperwork, or property purchase documents. So yeah, in some cases, the information that we needed was in an image inside a PDF. So first we have to process the PDF, locate the image, extract the content. So it was a long process. So it was not feasible. So we moved to our second option that was using a Microsoft Document Intelligence that had multiple pre-trained models and foundational models. So we realized with this solution, we were able to handle large volumes of data and also to work with different formats. So this could be like PDF, images, TIFF, Word documents, and others. We tested first the invoice model and the ID model. So the ID model worked very well in extracting information from driving license, passport, and also the invoice model performed well on documents that have like the format of an invoice. Usually here in the UK, all the user information in documents that are the name, address, postcode are located on the top left of the document. So for those documents, this model was performing well. But other documents like the tenancy agreements or legal paperwork, we were having some issues in the extraction because the information was not located where it was supposed, following like this invoice format. So for that, we tried the layout model, which is a model that is able to recognize the spatial layout of the document. So it's able to recognize headers, section tables, images tables, and so on. However, this model doesn't output specific information compared to the invoice model that can tell you what's the name of the customer, the address, the date of issue of the document, and so on. So given like these results of this testing, we decided to create a hybrid solution where we will be using the layout model from Microsoft Document Intelligence plus a GPT 3.5 Turbo for the extraction. Again, we tested with multiple prompt strategies depending on the use case and the information that we needed to extract. And we realized that we were able to handle a large volume of data with different formats and structures, and we were having like really high accuracy in the extraction. However, this approach solved our business problem, right, in extracting information from documents. But then we thought, okay, this process is going to be automatically, so users are going to upload documents We're just trying to reduce the headcount or the human intervention in processing these documents. So we will not have a person or a human validating the quality or the authenticity of these documents, right? So that is when I propose to make this solution like more robust and include 3 more functionalities. So we designed an automated document processing solution that automatically can extract, process, and verify data across different formats and data structure. So the first feature that we added was a document quality assessment and a document classification. So in this step, what we do is we verify the quality of the document in terms of contrast, blurriness, brightness, and so on. So if the document meets some specific criteria, then we approve the document and we are able to process it. At this stage, we also classify the document using, again, a GPT model based on the content of the document, because depending on the document type is the document intelligence model that we're going to use for extraction, or are the entities that we are going to extract from the document. Then we have the data validation step, where we can accurately cross-verify data extracted with user input or between documents. So we thought like we could have many use cases. For example, an application process where a user needs to fill in an application and then uploads a document to support that application. So probably we will need to compare that the information provided in the application form matches the documents that are uploading. Or another use case could be a mortgage application where a user provides multiple documents to support the application, and we will need to verify that all those documents corresponds to the same user. And finally, well, we have the fraud checks. Here we verify the authenticity of the document and detect any modification or fraudulent alteration. As this is going to be an online process without like human intervention or minimum human intervention, we need to make sure that the documents are real, are not edited by a user. So I will deep dive into each of them in the following slides. But before, I would like to talk about the benefits of this solution. So what we have seen is we have a great cost saving because our system can reduce the additional staff to handle, for example, a high volume of applications. Also, we can improve operational efficiency because our system eliminates the need of manual check or minimizes human errors. And scalability because, well, we are using Microsoft Document Intelligence. We're able to process thousands of documents with different formats. So our solution is easily scalable and adaptable to other business units. So let's start looking at each of these features. The first one is the document quality assessment. So yeah, before I continue, I would like to mention that all the documents that I'm presenting here are synthetic documents. So the information in the documents is not real. I created these documents using like the format of real documents, but I use a Python library to create like fake names, addresses, postcode, and fake information around the documents. So if anyone is interested in learning how I created these documents, I have a blog in Medium where I explain it, all the steps. In case I show a real document, I will just cover personal private information. Using my synthetic documents, I simulated different variations of the same documents with different formats in terms of blurriness, contrast, darkness, and so on. And based on this, I calculated like a confidence interval. So all the documents that were like inside this confidence interval of quality will be approved and processed. Any other document that doesn't have all these characteristics will be rejected, as we cannot guarantee a successful extraction and processing. So how we calculated this threshold? Well, we use the output from the layout model from Microsoft Document Intelligence, which provides a confidence score for each of the words extracted, right? So we didn't use all the confidence score of each word. So depending on the use case and the document we were processing, we will just filter out a specific content and evaluate the quality of this extraction based on the confidence score, and we'll define our parameters. So in the following slides, I have some of the results of this testing. So this was a use case where the user has to provide a document as a proof of residency. So the entities that we needed to extract were name, address, postcode, date of document, and also classify the document type. So in this document, what I did, I applied some blurriness, a low level of blurriness to the document. And as we can see from the output, our AI engine is able to classify the document correctly. Then, well, you have to believe me, but this council tax statement has two names on it. So one corresponds to Miss and the other one to Mr. We saw an impact on the address. So it doesn't start with 37. The real address starts with 3/7. The postcode was correctly extracted. No issues on that. But then the date of, also the date of document is correct, 15th of March, 2024. We can see that here in the document date of the issue of the document. Then I increased the level of blurriness to this same document, and we can see that our engine is classified the document correctly, extracted the name correctly, had the same mistake in the address. And in this case, it couldn't extract the postcode, right? So it had a major impact in that entity. The date of document was correct. When we increased the level of blurriness, we started having more impact on the entities extracted, right? So in this case, as we can see, it was only able to extract one of the names, and it was not even the complete name. The address is completely wrong. As we can see, in this case, it starts with BP when it previously was 37, where the original was like 3/7. Again, we couldn't extract the postcode, and in this case, the date of document was completely incorrect because it outputs the period for which this council tax statement was valid, that is found here in the middle of the document. So yeah, we did 14,000 tests with different documents combinations, and based on the output of Microsoft Document Intelligence with a confidence score, we calculated this threshold to accept or reject a document based on its quality. The second feature is our data validation. So at first, I thought this was going to be an easy task, as there are many natural language processing to compare strings like cosine and other metrics that could tell us if two string matches. However, it became very challenging, especially when dealing with addresses, as addresses can be found in different formats. So here I'm showing some examples of the challenges that we face. An easy one was when we realized that some names in documents contain like the titles, like Mrs., Mr., Doctor. So we have to do some data cleaning to remove titles from names before doing the comparison. Also, some addresses will contain extra words like flat, building, avenue, and so on. So we also will remove that from addresses. And in case there are any abbreviations, like for example, ST for street or AVE for avenue and so on, we will complete the word before comparing the strings. And there were other cases like the one on the right, where we only have like the first letter of the first name of the user, right? Here I'm presenting other examples for when we were comparing extracted information with account name. So the account name was for a person called FM, But in the document, there were two names, one with SL and the other one with FM, right? So it was these kind of examples reduce our similarity score, rejecting the document saying there is no match between the names. So we'd have to find a way to find the name that we were interested in the document before doing in the extracted name before doing the comparison. More complex examples are like this one, where the account name was for SL, but the extracted name from the document was Mr. S and Miss FL. So we had to design methods to compare the exact characters and string that we wanted. And here is just an example of a synthetic address in multiple formats that we could find them. We simulated this in multiple documents to see what was the best way to compare them and get like a high accuracy in comparing the scores. Okay, so before I move to the projects, I want to explain like the overall process of document processing, the workflow. With this diagram. So first, we will have our input data, that is a document. Our second step is the extraction part. So first, we're going to use the layout model to extract the content of the document. Based on the output, we run the quality assessment check. If the document passes this assessment, we proceed with the document classification, and based on the document classification, we extract the information that we need from the document. Then we have our confirmation step that, depending on the business use case, we can validate it against a user account or between documents or other use case. And our output will be like the entities extracted and the validation of these strings. And parallel to this process, we run the fraud checks. Okay. Yeah, for the fraud checks, I want to start showing this example that I really like. It's a post that I saw in LinkedIn a while ago when I was researching about like fraud checks. And I wanted to show it because I think nowadays computer vision techniques are very powerful and can be used to in fraud detection, specifically for this kind of document processing use case. So in Mexico, in the past, there were so many presidential election frauds where votes disappear. So it was common that someone would vote and then in the results show that that person didn't vote or the vote went to a different party. So people started like a social movement called Yo Ya Voté, which translates to I already voted or I have voted, to try to reduce these election frauds. So this movement consisted of people posting a photo of their thumb with the ink after voting and saying like Yo Ya Voté, no? But I think people were doing this with a purpose because they wanted their vote to be counted. But they never thought about the risk of doing this, because with the advancements in AI and computer vision, we can process this image and highlight every single detail of it. And when I say every single detail of it, this will include the fingerprints. So yeah, I think this is a very interesting use case because when I saw that, I said, okay, we are able to highlight every detail of an image, like the fingerprints. We can use this same technique or strategies to highlight every single detail of a document. And that's what we did. So these techniques are usually called digital forensic techniques. And I will just explain how we automated this process. So our fraud checks model consists of a set of tests to determine the authenticity of the document, right? So we include checks like identifying metadata inconsistencies, font anomalies in font characteristics like type, size, blurriness, text alignment, compression patterns, and structural similarities. So I will explain each of these techniques in the following slides, and I will give some examples of how they work. So the first one is called the error level analysis, which is a digital forensic technique used to detect inconsistencies in images. So these inconsistencies can indicate if an image has been manipulated. So how this technique works, so we have our original image, we compress the image to a lower quality and then analyze the compression levels. So the idea is that all the elements that are original in the image will compress at the same rate, while all the elements that had been added or edited in the image will have different compression rate. So by identifying this different compression rate across the image, we can identify the areas that had been edited. So here I'm comparing two documents. The one on the left is the original one, and the one on the right is the edited document. So in the original document, we can see like a very even distribution of the compression rates highlighted in colors like orange, pink, and purple. But in the edited document, we can see a lot of noise, especially on the edge of some elements of the document and between the section. So this would be like a sign of edition in the document. And actually, this document was edited in Photoshop. So to determine, because we wanted to automate this process, we needed different methods to analyze the result of this analysis. So we designed multiple statistical analysis on top of that image to determine if it has been edited or not. So these techniques include statistics about the edge length, edge intensity, outlier analysis, and others. Here I'm presenting like the top three or the most relevant to show if an image has been edited. So the first one is called the spatial correlation, or also known as MORAN-I, which measure the spatial correlation between pixel intensities and detects unusual clustering patterns in pixel values that can indicate that an image has been edited. Then we have the edge length, which is the total count of edge pixels in the image. So shorter edge lengths can indicate potential tampering, as edited region often blur or distort natural edge boundaries. And then we have the mean range metrics or mean intensity, that is the average intensity of pixel values between defined ranges. So identifying unnatural intensity distribution can indicate editing. So these plots show the distribution of these three statistics over 5,000 images. And what we do is to analyze thresholds. So we define 4 categories of definite fraud, probable fraud, possible, and none. So in the case of the spatial correlation, we will mark an image as fraud if it has a value lower than minus 1.1, which is highlighted here in kind of red color. The probable interval is in orange, and then the yellow will indicate a possible, and the gray area, it's no fraud. So we do this for each of our, to all the statistics, and we labeled the image according to all these, the results. And then we have like some business rules to have a final outcome from all the statistics that we calculated. So our data sample is around 15,000 images. And the second analysis that we have is the metadata analysis. The metadata of a document provides important information about like when it was created, when it was edited, the tool used to create it, and so on. So what we do here in this analysis is to identify some anomalies in the metadata, right? So using the same document that I presented previously in the error level analysis, I'm showing here the result of the metadata. So we call the fraud indicators to the metadata tags, like for example, creator tool, document ID, and so on. This is the value that we found in the metadata, and then we also have a decision. So this decision has the same 4 categories as the error level analysis that could be definite, probable, possible, and no fraud. And the decision can, we provide a recommendation on how to label these values, but it will also depend on the use case. So for example, in this case, the use case was that all the documents that were created with Photoshop will be marked as definite, right? We also have other evidence that this document was edited because some important elements of the metadata, like the document ID and modified date, were removed from the original metadata. Here is another example of a document that was also edited. In this case, the result was probably edited, as there were some signals of edition, like for example, the profile creator and device manufacturer were removed from the original metadata, and also there were some inconsistencies in the profile date, which was 2016, but the document was showing dates like 2023 and so on. And finally, we have our X-ray analysis, that with this analysis, we're able to identify hidden text or content and some font anomalies. So this technique is particularly useful for uncovering modifications in the documents where people add new text or images to cover original content, right? So many documents, especially those created with Adobe Photoshop or PDF editors, consist of layers. So each layer can contain different elements such as text, images, graphics, and so on. So with the X-ray analysis, we can examine this layer to identify any inconsistencies or additions. And then we can just see if in a new layer or an existing layer contains new images that has been placed on top of something that was originally created. So here I'm showing some examples of the image on the right. We are highlighting the font anomalies in blue, that are the user details where the name, address, and postcode are located. And the image in the middle, there are some editing tools that nowadays use AI to remove or edit content, and they have like this capability called whiteout, or you can just delete text on a document and then just put new text. So all these kind of editions can be like discovered as well with this technique, and that is what we're showing in this image in the middle. And the one in the right, we can find and highlight where new text is found. So that is like someone wrote new text to cover the previous one, for example, in case you want to modify the date of a document, or you want to change, like in that document, the reference ID or something. So the goal is that with all these combined tests, provide guidance to determine whether the document is authentic or not. So an important thing to mention is that this solution will not reject the document itself, like saying this is fraud. Instead, it provides all the evidence, and a human can just validate the evidence provided by the AI, and then just can take the final decision if the document has been edited or not. And the way we deliver all this evidence is what we call the AI explainability engine, that it outputs a PDF report with all these fraud checks results. So for example, we have a section with all the metadata results where we will put like all the key tags that we found in the metadata, the values and the outcomes. And then, well, we don't expect people to really understand what the metadata means. So that's why we put an explanation and a description of all of these keys, and we provide a summary of the results. Then in the visual evidence, we have the results of the error level analysis, where we provide also the outcome. So for example, in this case, the document was marked as probable, as we saw some additions on the user details. We provide also the results of all the statistics, and there is an example of these statistics. And we also provide all the evidence of the outlier analysis or the anomaly detection analysis. And the X-ray analysis, in case we find some hidden text or new text covering text, the original text, we will show this is the hidden text and this is the visible text and the location in the file, right? This is an important part because we have some use cases where people can upload evidence, for example, of proof of residency. And to do so, they will use a bank statement, but they don't want to share information about their account number, their source code, or maybe of some of the transactions. So we have seen cases where people cover that information from the document. So those cases are valid additions in the document. So that will not flag a definite outcome in the result. So this is the tech stack that we are using to run the projects. So yeah, mainly we are using OpenCV library from Python. That is a computer vision library that contains thousands of algorithms to process images and many machine learning algorithms such as fully convolutional networks and UNets that we use for task requiring pixel-wise comparison or analysis. We also use Poplar, that is a library that allows you to convert PDF to images. For the metadata analysis, we're using Exit tool. We are also using document Microsoft Intelligence for our X-ray analysis so that we can compare what's visible on the document to what we can find in the different layers of the document. And then we use different AI and machine learning libraries for anomaly detection of these documents. So now I will run a small demo on how our document processing solution works and how also the projects work. So I'm just going to exit this window. Hopefully you can see this one. Yeah. All good. So first I'll start by showing how we process documents. So I'm just going to browser a document. In this case, I'm going to upload bank statement. So again, all these documents are synthetic data. They are not real data. So what we do, we can see the different steps, how we connect to Azure, to document intelligence, and then to Azure OpenAI to do the extraction. So let me first open this document and highlight some of the challenges, right? So this is the common format of the UK documents, right? We have the user information on the top left with the name, address, and postcode. Here on top, we have the date of issue of the document. We don't have anything that indicates that's the date of issue, but by analyzing the document, we can know that. This document contains multiple dates. For example, the period for which this bank statement is valid. Other days like the balance dates, and also, that's one of the challenges. However, when we see the output of our AI engine, we can see that it has been correctly classified as a bank statement. It has correctly extracted the information of the user, the name, address, and postcode, and it has correctly extracted the date of the document, despite of being multiple dates on the document. I can show another example that also faces some challenges. This is council tax statement, similar to the ones that we saw. So we connect to document intelligence, we extract the content, we open Azure OpenAI to call GPT model to perform the extraction, and then we do the verification of the entities extracted. So we can see here this council tax statement has multiple addresses. The first one corresponds to the City of Edinburgh Council. We have the address from the user on the top left, but also information about the property on the top right. We have the date of issue, in this case was 12th of March 2024. And similar to the other one, we have multiple dates about like the tax financial year and so on, or for the period for which this council tax statement is valid, right? When we see the output of our model, it's been able to classify the document correctly and has extracted the information of the user as it is found in the document, and also the date of issue of the document is correct. When we simulate the registration process, I have already input some data. So this corresponds to the bank statement that we saw previously to Maria Potter, and I have already put all the information about the address and postcode, right? So then we will upload our document, that is the bank statement. Let's just wait while we get all the information that we need. It's important to mention that we built this demo using Streamlit, but this is just for demoing purposes, so it's not like the real final solution that we deliver to clients, right? And when we go to the verification step, we have how we can compare the strings, right? So for example, we can verify our input data, which I provided, that was the name of the user with the one extracted, and we have 100% match. Here in the address, we have some discrepancies because there is a different format on the address. This was like a single word, but in the document it was like 2 words. And also the number includes some extra characters, which match the matching score of the address 96%. The extracted postcode was correctly extracted and matches with the input postcode, so that was a 100%. And finally, we just calculate the average of the 3 matching scores. So yeah, we can see like if we, for example, modify some of our input data, all of these metrics will change. The matching score for the name will reduce to 88%, and that will also reduce our overall matching score. So yeah, when we did the verification, we have around 5 methods to compare the different string, plus all the rules that I explained, for example, removing titles, extending addresses, and so on, to do the score, and then we just take the average of all those metrics. So this is how we process our documents. And for the fraud checks, I will run some examples. And the first one corresponds to a utility bill. So what I did in this utility bill was to modify the postcode of the user. I modified only the last 3 characters of the postcode. So as we're going to see here, it's going to be rejected on one of the error level analysis. In some cases, there are people that know how to edit the metadata so that it doesn't show the edition. So that's why we also simulated cases like that, where one of the checks will pass, but the other one will fail. So here in the visual evidence, I like this one because, like I said, in the error level analysis, what we can see are the different compression rates, right? So everything that is original from the image will compress at the same rate, and everything that has been added or edited will compress at a different rate. And here is an example of that one. So where the name of the user is located has the same compression rate as the address and the first characters of the postcode, right? But the last 3 characters of the postcode, which I edited, we cannot actually see them, and shows like completely different compression rate. So for this, I created another image based more on the blurriness of the font, and we can see how the last 3 characters of this postcode have like are brighter compared to the rest of the strings, right? Yeah, so I can run another one that is the document that we saw in our presentation that was edited with Photoshop. And we can see how this is going to fail the metadata check, and also will show some evidence of the error level analysis. So yes, we can see here it has found that it has been edited with Photoshop. And when we see the reasoning from the error level analysis, it says that the image is likely edited. And if we go to the visual evidence, we can see the variations and the compression rate. So on the edges of each of the section of this document shows a lot of noise and inconsistencies. Also, here is another visual evidence where we can see like very bright areas that shouldn't happen, because if the image has the same compression rate, everything should be like plain or constant in the document. So yeah, that's me demoing this solution. And yeah, just if you have any question, anything you want to ask me about how this works, I'm just more than happy to answer.
I don't see any questions in the chat. I see a few applause going up from the chat. Does anybody have any questions? You can feel free to come off mute if you want to just speak them into existence.
I don't have any questions, but it was really cool seeing the documentation imaging and seeing how the different compression showed where you had the different layers and how you can use that to show editing and that the document has been edited. I've always been curious about that, so it's really cool to see that. So thank you.
Thank you so much. Yeah, I'm really glad you enjoyed.
And so that was a pretty cool presentation. I haven't seen that in action myself either. So I guess if no one has any questions, we'll end the session and just say thank you. Again, we're going to be uploading this to YouTube unless Andrea complains and tells us not to. That should go up in the next day or two, probably in the morning when I'm awake at really odd hours. And we want to just thank you for presenting to us. It was a great presentation. We really enjoyed it. We'll send a follow-up email with the links.